Welcome everybody to London Futurists. In a moment I will be introducing Niki Wiles, who will be talking about the radical potential of blockchain technology. My name is David Wood. I've been chairing these London Futurist meetings for 7 years now. We've had over 100 meetups over these years. Very glad to see more and more people taking futurism seriously, because the future is coming faster than we used to think it would come. And many things are changing more quickly than people had expected they would change. So rather than looking 100 years out for some of the huge changes in human beings and in human society, people can take it much more seriously, the possibility that within our own lifetimes, within one human generation, things will be very different from what we're used to. And one of the drivers for change is this kind of decentralized, secure validation technology called blockchain, which hasn't had much press in its own right. There's a lot more press gone into Bitcoin, and some people have said that Bitcoin is the financial singularity corresponding to the notion of a technological singularity. Technological singularity is when things will start changing in a completely unpredictable sense, because we will have artificial intelligences which are cleverer than humans in every significant way. Then how can we foretell what's going to happen next? So that's the technological singularity. And various writers in the future have said, well, with Bitcoin and the many other financial disruptions that will be enabled by blockchain, it's just in the same way very, very hard to see what's coming next. But it might be that with a surprisingly short amount of time, there are lots of new businesses, lots of new practices. So I don't know, just as a poll before we get going, and how many of you are bought into this? How many of you think, yes, this technology is going to have a big impact on your lives and on your family's lives and your friends' lives within 10 years? Well, quite a lot, yeah. So who's skeptical? Who thinks this is just a whole lot of technologists getting excited and so on? Oh, there must be some skeptics in the audience. Thank you, sir. Why are you a skeptic?
I work in technology, and then I see a lot of people that don't understand currencies and finance think they understand Bitcoin, so
right.
Just want to find out a bit more.
Okay. And it is true, almost every technology which ends up disrupting things is for a long time overhyped. There is this hype cycle. But for a long time people get more excited in the short term than is justified. And then there's a kind of disillusionment comes along. And then eventually the accumulated weight, the accumulated set of deliverables has grown so large that suddenly there's this disruptive breakthrough. Many people were skeptical about the internet. Many people were skeptical about changing lots of business to use the web. They said there wouldn't be any significant amount of music bought on the web. There wouldn't be any significant amount of videos watched on the web. It'll all be dominated by real life. And for a long time that was true. For a long time that continued to be true, until suddenly there was the tipping point and there was a significant number of people who had got used to the new ways of working. So possibly the same with blockchain. So having said all that, I'd like to introduce our speaker for the day. He has been looking at this area a lot harder than me for 3 years.
Yeah.
3 years. So in this field, 3 years is a long, long time. And so I'm looking very much forward to finding out some of the substance behind the hype and some ideas on what will be disrupted. So let's welcome Niki.
Well, thank you, David. How is my volume? Can folks hear me all right? Not too bad, lovely. All right. As David says, in this presentation, I want to get you guys thinking about the implications of a relatively new innovation called blockchain technology. I'm dividing this talk into roughly two halves. In the first half, I'll explain what blockchain technology actually is. It's hard to do that without talking about Bitcoin, so I'll try and describe the sort of processes behind Bitcoin and what makes it work. But then in the second half of the talk, we'll kind of start to leave Bitcoin behind a little bit, and I'll share with you some of the new and interesting projects that are just starting to emerge, that are gaining a bit of traction against competitors in various different industries. Then at the end we can talk about some possible future scenarios about what sorts of things might happen should blockchain tech really start to catch on. And then some questions, and then hopefully we can all get out of this basement and into the pub. So it all began with Bitcoin. So back in 2008, the white paper that describes Bitcoin was published on a cryptography mailing list called metsdoud.com. And the author is a person referring to themselves as Satoshi Nakamoto. We know that this is a pseudonym. We still don't really know for sure who Satoshi Nakamoto actually is. There are theories, and if you want to hear my theory, then catch up with me later. But in this white paper, Satoshi described Bitcoin as a purely peer-to-peer version of electronic cash that would allow online payments to be sent directly from one party to another without going through a financial institution or a third party of any kind. And this is something that had never been achieved before, so this really positioned Bitcoin to be the world's first cryptocurrency. But a bit of context for you guys. So by 2008, we'd actually had digital currencies for well over a decade. Companies like eGold and Liberty Reserve have been around for 11 or 12 years by then. In this picture you can see eGold's then headquarters out in Florida. So these places have physical locations. Basically, with these sorts of businesses, you'd wire them some currency, often dollars, and they'd then give you an online balance that you could then send to other people who are sharing the same network as you. In the case of eGold, you'd send them dollars and they'd give you a balance denominated in ounces of gold. In the case of Liberty Reserve, you'd send them dollars and they'd give you Liberty dollars. If you sent them euros, they'd give you Liberty euros. And then you could send this sort of virtual currency around inside the network. And at their peaks, these businesses were doing billions of pounds in transactions per year, and they really were the trailblazers in the digital payment space, and really sort of paved the way for the likes of PayPal to become successful. But in a post-9/11 world, particularly with the signing into law of the Patriot Act, the US government started to put in place newer and stricter definitions of what's known as a money services business. And this was ostensibly to prevent money laundering and the financing of terror. Now, both eGold and Liberty Reserve ended up falling seriously foul to these regulations. The founders of both companies ended up pleading guilty to a whole bunch of charges around running an unlicensed money transmission business and also conspiracy to launder money. Now, Liberty Reserve in particular, by this point, had become a bit of a firm favourite amongst criminals. And it's estimated that Liberty Reserve laundered over $6 billion in criminal proceeds. Now, and this was all kinds of different crimes as well, like credit card fraud, identity theft, investment fraud, child porn, all kinds of horrible stuff like that. So, needless to say, jail time was served in both cases, and ultimately both services were shut down. And that's despite one of them being located out in Costa Rica, which just goes to show you the force that the US government can exert if it kind of feels called to do so. But getting back to Satoshi Nakamoto's vision of this method of transmitting digital cash in a way that does not rely on a government, a financial institution, or really a third party of any kind, it's important to remember that prior to that white paper, all digital cash systems that have been successful were centralised. So by centralised, what do we mean? There's an operator who's sitting in the middle, and then the users are sort of arranged around the outside like spokes in a wheel almost. And from a practical point of view, if this guy wants to make a payment to this guy here, they can only really do so by involving the person who sits in the middle. So what they're effectively doing is asking this guy in the middle to update the central ledger of balances in favour of the person that they want to pay. And the person who's initiating that has to trust that the operator is going to do so faithfully. Now, Satoshi Nakamoto was not alone in realizing that this kind of centralized architecture was less than ideal, basically because it puts so much power in the hands of central authorities. So he knew that a better solution was always going to look much more like a decentralized or distributed sort of approach. And I think it helped that around about the time when Bitcoin was being created, we already had BitTorrent, which was like a real-world example of a successful distributed system. So it's pretty obvious that centralized systems like eGold and Liberty Reserve, and for that matter, any centralized payment system, eBay for example, they all share common disadvantages. And at the heart of the problem is this centralized ledger of balances that essentially is controlled by a single entity. So what we have here are similar sorts of attack vectors. The three classic attack vectors would be, number one, what if somebody decides to actually shut down that central database? And it could be a government that does that, like in the case of eGold and Liberty Reserve. It could be a disgruntled ex-employee. It could be, the cleaner is, hoovering up in the server room and just nudges out the power cable to the big web server. Doesn't matter. The point is that centralized systems tend to have that sort of vulnerability, that single point of failure. Second is, of course, corruption. So if you have a third party that has privileged access onto a set of monetary balances, they can effectively choose to put themselves in the money printing business by creating a new account and then funding it with a balance. They can pilfer funds from other accounts at will, and they can even shut down accounts at will also. Lastly, of course, security. So if you operate a system that controls a high-value ledger of monetary balances, then you're going to be a target for hackers, because there's a single point that people can attack in order to change the state of that system in their favour. So centralized systems have all of these sorts of well-known problems, but prior to Satoshi Nakamoto, nobody had really figured out how to do digital cash in a decentralized way. And the major challenge, the sort of biggest technical impediment, is something known as the double spending problem. So basically, if you have a whole bunch of information that describes the balances inside of a payment network, and that's all essentially data, and as we know, data can be changed, it can be copied. How can you prevent people from spending the same balance over and over again without having to resort to making the system centrally controlled? That was the big problem that no one had solved. But it just so happens that this exact problem is something that is fairly well known in computer science. And the classic sort of formulation of that problem is known as the Byzantine generals problem. The description of the problem comes with a bit of a story. So I'll tell you the story. Basically, you've got this rich city of Byzantine. It's the wealthiest city of all time. Its streets are literally paved with gold. If any of you guys watch Game of Thrones, imagine the great city of Karth. So basically what you have here is a lot of wealth that's centralized and a lot of haters. So around this great city you have lots and lots of tribes who are camped out, and each of those tribes has a general, and each general commands an army. Okay. However, none of these armies are a match for the city walls of Byzantine. However, if just half of those armies could coordinate with one another and attack the city together, they'd be successful. But if an attack was staged and less than half of the armies showed up, the battle would be lost and everybody would be killed. But it's even worse than that, because the generals can't really collaborate easily because all the tribes really hate each other. So they can't all meet because of fear of assassination. So they're left effectively with communicating via riders on horseback. And even that's prone to problems because these guys can get shot down in transit, and also they can get bribed by other generals and fed misinformation that's intended to trick them into staging a failed invasion. So what you kind of have here is a kind of consensus problem, and it's consensus under really adversarial circumstances. And I hope you can kind of see that this problem that I'm describing here is very much like the problem that Bitcoin is intending to solve. Except for the fact that instead of having generals, you have participants inside the Bitcoin network. Instead of trying to agree on when to stage an invasion, we're trying to agree on a set of monetary balances inside the network. And instead of riders on horseback, what we have are TCP/IP packets being communicated across the internet. For those of you who know your networking, you're probably familiar with the idea that TCP/IP packets can be maliciously crafted, intending to dupe the network. They can also be, they can also fail, so through natural sort of networking issues, a packet can fail to transmit. It can be blocked by an adversary and rejected. And it can also be blocked by an adversary, tampered with, and then kind of retransmitted in a sort of man-in-the-middle style attack. So Satoshi Nakamoto was the first to describe a solution to the Byzantine general's problem that works really well for distributed systems. And this solution, as you probably guessed, is called blockchain technology. So let me just quickly go into a little bit about how this solution actually works in practice. So in Bitcoin, all the participants in the network have a complete record of every single transaction that's ever been conducted in the history of the entire network. So, and that goes all the way back to the very first transaction that was ever conducted by Satoshi Nakamoto. He sent a payment to a crypto enthusiast by the name of Hal Finney, and this was all the way back in January of 2009. So the transaction system in Bitcoin works a bit like this. So any participant in the Bitcoin network who wants to, and it is optional, so anyone who wants to, can use the computing resources at their disposal to work on a certain type of mathematical problem. And the nature of this problem is such that its difficulty can be adjusted dynamically, such that somebody in the network is going to produce a valid result on average once every 10 minutes. And it's one of the cool properties of the Bitcoin network that allows for that to take place. Now, there's no shortcut to answering this type of problem. Effectively, there are billions of valid solutions to this problem, but there are a vastly, vastly greater number of invalid solutions. And the only way to get a valid solution is by a process that's kind of like brute force guessing. So you're guessing over and over and over again, but at incredibly high speeds. And if you manage to stumble on a valid solution to this mathematical problem, then you can submit that solution to the Bitcoin network, and you'll be rewarded with some Bitcoin. And this process is known as Bitcoin mining, because there is quite a strong analog with the process of mining for gold. So on the screen here, what you're looking at is a Bitcoin mining rig. So somebody has spent a lot of money to buy a whole bunch of computing hardware. This hardware is crunching away at that mathematical problem in the hope that he'll stumble upon a solution, submit that solution to the network, and earn some Bitcoin. And I guess the hope is that over time he'll earn Bitcoin that will be of such a value that it will hopefully pay for all this gear and hopefully make some kind of a profit. So while all of this this guessing, this computing is going on, the actual participants in the Bitcoin network are all using the Bitcoin network for what it's intended for, which is a payments network. So people are just sending payments to each other inside the network. Now, when I send a payment in the Bitcoin network, I don't literally send a payment to you. What I actually do is more like broadcasting the details of the payment that I want to make to the entire network. So it really is more like shouting in a crowded room than it is sending a private message. So the way to think of it is that everybody in the Bitcoin network is seeing all of the transactions as they occur. Okay? So as a node in the Bitcoin network, I'm kind of sitting there and all these transactions are coming in. And what all the nodes do is they kind of collect those transactions up and put them in a little pile. And then at some point, once every 10 minutes actually, somebody in the network will stumble upon a solution to the aforementioned mathematical puzzle. And when they have a valid solution, that person then has the opportunity to take all of those transactions that they've got, to bundle them up into something called a block, and then to submit that block, to broadcast it to the entire network. And in exchange for that, they'll get a Bitcoin reward. So from the point of view of everyone else, they'll see a block coming toward them through the network, they'll capture it, everyone's going to get a copy of this block, and then each node has to decide whether or not they trust it. So what they'll do is they'll open up that block, have a look inside, and decide whether or not they reckon it's valid or not. And that's really easy to do because, don't forget, all the nodes have been receiving copies of all the transactions, so they'll say, well, this is what I've received, this is what's in the block, they look the same, it's fine. And also they can look at the individual transactions, and because they're all signed using public key cryptography, they're really easy to validate, so it's pretty easy to make sure that everything's legit. If there is a problem, they just discard the block and pretend it never arrived. If it looks fine, they tack it onto the end of the last block that they received, and then everyone starts working on the next block. And this process just continues, and these blocks of transactions come in, and over time they are built one on top of another until eventually you have a blockchain, and that's kind of where the language comes from. Is everybody sort of with me so far? So to recap, Bitcoin was the first true cryptocurrency. It's the first system of digital cash that's built on a decentralized ledger that's provided by a peer-to-peer network. And it also solves this double spending problem in a really sort of novel and elegant way. So, in my humble opinion, blockchain technology is easily a Nobel Prize winning level of achievement. It makes all kinds of interesting things possible that simply weren't possible before. So here are some thoughts on what blockchain technology sort of represents as an achievement. So I like to think of the blockchain as a decentralized database or ledger with network-enforced processes for updating the database. It enables participants in a network to collaborate and to form a consensus without needing to either trust or pay any third parties. From a kind of computer science point of view, I like to think of blockchain tech as an entirely new class of decentralized data structure. I also like to think of blockchain tech as a general purpose technology that can be applied to disrupt any centralized system that coordinates valuable information. And when I use the word disrupt, what I mean is to provide exciting and competing alternatives to. So if you can think of any centralized system that's run by a central authority, where that central authority is causing problems, or maybe there's just the suspicion that they might be causing problems in the future, or maybe just bothers you that you have to trust any central authority at all, then I hope that blockchain technology will spring into your mind as a possible solution or a possible competing solution to solving that sort of class of problem. Third quick point is that blockchains are robust enough to work even in the presence of powerful third parties who'd like to prevent users from participating. So this has clear implications for democracy, voting, liberty, and most definitely freedom of speech. So let's kind of sum up the main properties of blockchain-based systems. If there's one slide to take away, I think it's probably this one.
Are you happy to take questions as you go along?
Yeah, sure.
I probably missed something, so apologies for schoolboy error type question, but if the new transaction and indeed the new mined solutions are broadcast to everybody in the network, doesn't that mean you can't have a confidential transaction? I thought that was one of the benefits of the system.
Blockchain, Bitcoin specifically is an extremely transparent system. So the details of every single transaction are completely public. All that's kind of opaque is the addresses that people use. So in Bitcoin, when you have a Bitcoin address, it doesn't have your name on it. It looks like a long and garbled sequence of characters.
Like an IP address.
Yeah, but even more complex than that.
And you can't reverse engineer it. You can't find out who it is.
It's possible to. So it's in terms of its anonymity, I put Bitcoin somewhere between. I say it's about as secure as a Swiss bank account. I'd say. Certainly, it's less anonymous than the cash that you have in your pockets. So there are attacks that you can use to try to de-anonymize Bitcoin transactions. So if you're a government, I think you'd probably much rather people use Bitcoin than digital cash, because there's a complete audit trail of every transaction that's ever happened, and if you can tie a human identity to one transaction, you've got a pretty good chance of sort of uncovering the other ones that they've done.
Right. And is that true of blockchain necessarily, or is that a Bitcoin specific?
That's Bitcoin specific, yeah. So it's entirely possible to imagine blockchain technologies that are more anonymous. In fact, some exist. Examples are Monero and Dash are examples of two competing cryptocurrencies that weigh more heavily on anonymity, and they use special approaches to mask the senders and receivers, so that there's sort of plausible deniability, and it's very hard to it's essentially impossible to sort of pin down who exactly was the sender and receiver in a particular transaction. Cool. Okay, so let's just run over some of the properties of blockchain-based systems. Number one, highly transparent. All participants can see the entire state of the network. As the gentleman just alluded to, that doesn't necessarily mean that all the information is in a human-readable form. It could all be encrypted, but the point of view is that it's all available. Secondly, we have a high level of resilience and a high level of availability. So the network is robust. There is lots of resilience in there. There's no central point of attack that you can use to bring the network down. This makes it a powerful form of censorship-resistant communication. Thirdly, we have trust and security. So because the mechanisms for updating the database, this distributed ledger, because they are network enforced, then there's not really any way to hack the network unless you can find an exploitable weakness in the blockchain protocol itself. Last of all, these benefits can often be achieved at really low cost, like especially in comparison to some of the centralized systems that we have operating out in the world, because today's centralized systems tend to involve lots of human beings, lots of intermediaries, middlemen that want paying. So transparency, resilience and availability, trust and security, potentially at low cost. Last of all, because blockchains are a mechanism for decentralized data storage, they've got great use cases in industries that are data rather than capital intensive. So anybody who listens to Rick Kurzweil is probably familiar with the idea that over time, more and more industries are becoming increasingly information technology intensive. And it's also the case that the economics of blockchain-based solutions are kind of piggybacking on three really interesting exponential trends. So obviously, first of all, Moore's law, so the cost of processing a bit. So blockchain tech tends to be quite processing intensive. You saw the picture earlier of the massive Bitcoin mining rig. Secondly, Kreider's law, the cost of storing a bit. So blockchain tech tends to be quite storage intensive. I mentioned earlier that in the specific case of Bitcoin, every participant in the network has a complete copy of all the transactions that have ever happened. That's gigabytes, so lots of storage. Secondly, Nielsen's law, the cost of shipping a bit. So blockchain tech tends to be quite network intensive because the entire system must communicate in order to form a consensus about the network. So it is possible that what we might have here is the beginnings of a kind of rising tide, because I think that the economics are gradually swinging in favour of these sorts of decentralised solutions. So over time, as driven by these three exponential trends, what we might see is decentralised solutions becoming sort of increasingly cost-effective when compared to centralised solutions. But where might some of this disruption start to manifest itself first? Well, in the second bit of the talk, I want to highlight some of the areas that I reckon are going to be first to experience this kind of disruptive impact of blockchain tech. So we've got finance, gaming, communications and media. Now, first of all, finance. If ever there was an industry that could benefit from that, transparency, and also the sort of automated enforcement of rules and regulations that blockchain tech potentially offers, then it's definitely the world of finance. Let's take a quick look at some of the areas where blockchain tech could potentially add some value. The first is cash and bank deposits. I mean, this is arguably the target that Bitcoin was designed to disrupt. Satoshi Nakamoto had a very low opinion of our highly centralized financial system. And cryptocurrencies, blockchain-based currencies, certainly have some potential to disrupt the fiat currency system, at least to the extent that they can mitigate what some people believe to be the problems with fiat cash and bank deposits. Let's just sum up these problems. Firstly, arbitrary inflation. So with Bitcoin, the money supply is subject to algorithmic regulation. So the quantity of money in the system, the number of Bitcoins, only gets expanded when a new block is successfully mined. And even this process is regulated by the network, such that the maximum number of Bitcoins that can ever be created is 21 million. So what we have here is a gradual tailing off in a sort of asymptotic curve toward that 21 million total that will never actually quite be reached. So the inflation in Bitcoin is very predictable, and it's not subject to the whims of governments and central banks. Now with fiat currencies, on the other hand, banks can and do create money at will. So banks create money in the form of loan deposits, and governments these days always seem to be tinkering with the money supply by using quantitative easing. So both of these forces, money creation via bank deposit and quantitative easing, both eat away at the value of the cash in your bank account. And some people think that this state of affairs is unacceptable, and those sorts of people tend to really like Bitcoin and blockchain solutions. Second is speed of transmission. So anyone with a bank account knows that it can take like 2 business days to do a SEPA transfer, and I did an international wire transfer. It took a week to go through. Bitcoin transfers, on the other hand, tend to be robust in around about an hour. So we can say that Bitcoin's probably several hundred times faster than bank transfers, depending upon what type of bank transfer you're actually doing. But there are other cryptocurrencies that compete with Bitcoin that are 10 times faster than Bitcoin. And there are also experimental projects that are about 10 times faster than the fastest cryptocurrency that exists at the moment. So I wonder if in a few years we might be in a situation where we've got blockchain-based currencies that have money transmission speeds that could be like 5 orders of magnitude faster than our legacy banking system. So cost of transmission, so the cost of actually sending money. Bitcoin transactions tend to cost a few pennies each, and that's regardless of how much money you're transmitting. So it's about the same whether you're sending $50 or $500 or $5 million. This little example here is of Western Union, because the remittances market is the one that's sort of most cited as the market that Bitcoin could most easily disrupt. So here we have Western Union, who are offering to take a 10% cut, a 10% fee on sending dollars in the US. And of course, a cheeky Bitcoiner has done their own little competing advert, which is 1 cent to send any amount of money to anywhere in the world. I think that price is probably a little bit understated, but you get the idea. You know, we're looking at about 100 times cheaper. Fourth issue has to do with difficulty of seizure in comparison to bank deposits. So if you're a Cypriot and your government decides that one morning they want to do a massive bail-in of the financial system, they can just confiscate your funds. There's not really much that you can do about it. With Bitcoin, for somebody to seize your funds, they actually have to involve you, because they need to get access to your private key, which is the piece of information that's required to unlock your balance that is personal just to you. Provided you're keeping that nice and safe and secure, you should be okay. For them to seize your account, they're going to have to steal it from you or trick it out of you, whatever they want to do. Last quick aspect is the size of transaction, and in particular the possibility for doing microtransactions. So every mainstream digital payments network that I can think of, it's basically impractical to send very small sums of money. You couldn't send, 50 pence through PayPal. The charges would be more than the amount that you were sending. But with blockchain tech, you really can send very small amounts of cash. And this has some really interesting use cases in the developing world, but also for machine-to-machine transactions too. I've got a slide later on about how blockchain tech might be able to provide some of the infrastructure that would provide for a future Internet of Things. Next quick idea has to do with provability of reserves. What does that mean? Well, how do you know that your investment company or your pension provider or your local bank aren't secretly operating a gigantic Ponzi scheme? With blockchain-based systems, using cryptographic signatures, there's a way that you can actually prove that you own a particular balance. And that means that in the future, financial audits could potentially be done automatically, algorithmically, and perhaps even fairly close to real time. Some Bitcoin exchanges have already started doing this. So one Bitcoin exchange that's based just down the road from here, actually, called CoinFloor. They're the first to provide a publicly auditable Bitcoin exchange. So anybody who wants to can just validate that they own the collateral that they say that they own. I think that this stuff is really exciting, because when one company does something like this, I think there's a lot of pressure on other companies to follow suit, especially when it comes to stuff like financial transparency. Because if one guy's doing it and you're not, then what have you got to hide? Is the question. Next one is this idea of trustless peer-to-peer markets. So right now, I think that financial markets are some of the dirtiest and grimiest places in the world. Banks of late have received over $2 billion worth of fines for market manipulation and rate rigging. Barclays alone was fined $40 million for Goldfix, $200 million for LIBOR, and the upcoming fine for the Forex rigging is probably going to be north of $250 million. So that's half a billion dollars in total fines for market rigging from a high street bank. There are many really interesting Bitcoin 2.0 projects out there. I encourage you to check them all out. The one that I kind of represent is Counterparty. But we have Counterparty, Ethereum, NXT, BitShares, eMoney. All of these projects are in a bit of a race to create really popular decentralized markets for financial instruments and assets. Now, this is super cool because in the case of Counterparty's tech, Counterparty offers a decentralized exchange which enables you to build markets such that people can transact and trade with each other without any middleman being present. And I think that's like a really, really exciting bit of technology. The upside of these sorts of markets is that they are highly transparent, and they could even potentially be regulated on the fly, perhaps using intelligent algorithms. So you know that there can't be like a market operator who's sort of sitting behind the scenes manipulating price signals, because that market operator has been completely disintermediated, leaving only a blockchain. And the other thing, of course, is that there's no trading fees. So that means that you can potentially have markets that are that much more efficient. Lastly, in the finance section, the unbanked. So there's 4 billion people without good access to banking and financial services. Blockchain tech can help here because, well, let's think of some advantages. Number one, payments are cheap. Number two, the possibility for doing microtransactions. And also, this idea that creating a digital currency wallet is something that can be done in like 2 seconds on cheap hardware like a smartphone, and compare that with the sort of comparative impossibility of getting a bank account if you live in like certain parts of Africa. Also, I'm interested in the idea of micro-lending in this space as well. Next big area is gaming, and I want to focus on gambling because there's some really interesting stories to tell, and a lot of money in this space, but also a lot of regulation that people want to sidestep. The first idea is has to do with provably fair gaming. So imagine that you are playing poker in an online casino. How do you know that the operators aren't manipulating the odds from behind the scenes in order to boost their own profits? Blockchain tech actually makes it possible to prove that everything is above board. This is an idea that grew out of Bitcoin and can actually be used with or without a blockchain. There's a poker operator called bitzino.com, that's Bitzino, who have a process for this that's quite interesting. I'll share it with you real quick. What they do is they shuffle a virtual pack of playing cards on their server, and then they hand you a code that behaves kind of like a mathematical fingerprint for that shuffled deck. Then, when it comes time for you to bet, you provide a number that's randomly generated on your computer. You can even do it by hand if you want to. And then you send that number to the operator, and they use it to then reshuffle the deck in a completely deterministic way. After all the betting's been done, and you've either won or lost, the operator then reveals the original shuffle of the deck to you, and then you can validate that against the hash that they gave you, and then you can also follow through the deterministic shuffle that would have happened based on your code. And all this is of course done automatically by the browser, but if you wanted to spot check it and do it by hand, you definitely could. Taking this idea one step further, we've got the idea of an entire casino built on a blockchain. Now there's a project called ChanceCoin that offers the ability to play several different casino games, all on a blockchain, using a cryptocurrency, a bit like Bitcoin, but it's called obviously Chance Coins. And Chance Coins sort of play the role of casino chips inside this ecosystem. And they can be bought and sold for Bitcoin on many different Bitcoin exchanges. So, like most casinos, the odds are stacked in favour of the house, but unlike most casinos, by holding on to chance coins and actually owning some of these, you get dividends that represent a share of the house's winnings. So this is a casino that's kind of almost owned by the people who own the casino chips. It's a fascinating sort of like community-style project. Now, there are heavy laws in the US that restrict online gaming, but imagine how difficult it would be to shut down a casino that had no employees, no offices, and no central operator. This casino is basically a bunch of source code on GitHub, and it runs as a layer that sits on top of the Bitcoin network, and it leverages that sort of data storage functionality that Bitcoin provides in order to essentially record all of these bets and decide who wins in a completely decentralized way. Next quick industry I want to look at is the communications industry. And the area where blockchain tech is already making the biggest strides is in censorship-resistant communication. There's quite a few good projects in this little section, but I've had to sort of cut it down to some of my favourites. The one I want to talk about is called BitMessage. This is a project that was created by a software developer called Jonathan Ware. It's based on the design of Bitcoin. Has anybody here actually used BitMessage? Nice, one person, okay. So BitMessage is essentially a messaging system that uses a peer-to-peer network and public key cryptography to create a kind of decentralized and trustless messaging system. And it hides not just the content of the messages, but also gives sort of plausible deniability about the sender and receiver of those messages. And it's kind of structured a bit like Bitcoin. So if you're a user inside the BitMessage system, you create an address for yourself, and that address has two parts, the public part and the private part. So the public part you publish to enable people to send you messages, and the private part you keep to yourself to enable you to decode whatever messages people send to that public address. So if I want to send a message in BitMessage, I go and find the public address of the person that I want to communicate with. I write them a message, paste in the address, and then hit send. And what happens next is that my PC will sit there churning away and processing quite heavily for a few minutes. And what's happening while it's doing this is that my PC is computing something called a proof of work. And that's very much like the solution that was being created in the whole sort of Bitcoin mining rig thing that you saw earlier. Basically, it's a mathematical problem that's hard to get a solution to. But when you've got a solution, it's really easy to validate that that solution is correct. Okay? And this is effectively a spam prevention mechanism to prevent people from flooding the network with loads and loads of messages. So any message that is not accompanied by a valid proof of work, it can just be discarded and ignored. Okay. So in BitMessage, when it's time to send that message, I'm not just sending it to you, I'm actually broadcasting it to the entire network. So everyone is going to see the message, but it's encrypted, and the only person that can actually decrypt the message is the person that has the private keys. Now, if my recipient actually happens to be online when I send the message, they'll just receive it and, job done, they got the message. If they happen not to be online, that's okay too, because every single node in the BitMessage network stores a chain of the last 2 days worth of messages, and collectively the network is just constantly trying to rebroadcast messages in order to get them delivered. Next quick area I want to look at is DNS, which, as many of you know, stands for Domain Name System. So DNS, for those of you who aren't aware, is the system that translates easy-to-read domain names like, Google.com, and it translates those into IP addresses that your web browser can use to locate the machine that's ultimately going to serve up the page that you requested. Now, the thing about our current DNS system is that it is highly centralized. And it's centralized in terms of its technology, but also in terms of how it's run. So there is a big sort of administrative body, which is called ICANN. That's ICANN, and that stands for the Internet Corporation for Assigned Names and Numbers. And these guys have an awful lot of power. So if you're the Pirate Bay or WikiLeaks, then you probably have a good idea about how easy it is to get your domain name confiscated if you start to annoy the wrong sorts of people. And this obviously has big implications for freedom of speech. But this centralization of the DNS system is probably the internet's biggest weak spot, or should I say the web's biggest weak spot. For example, if a really ambitious terrorist wanted to shut down a big chunk of the web, how would they do it? Well, they couldn't do it by shutting down all the web servers because there's millions of them. What they might consider doing is going after some of the root DNS servers. So each country has a small handful of root DNS servers that effectively delegate authority for domain name lookups. The exact physical location of these root DNS servers tends to be a closely guarded secret, simply because of that fear of attack. So the two problems here are censorship and also potential problems in terms of the resilience of the system. And let's have a look at how blockchain tech can add something to this picture. So Namecoin is a blockchain-based project in a similar sort of vein to Bitcoin, except that instead of having a blockchain just to store like digital currency balances, it also offers a really flexible database that can be used to store all different sorts of information. For those of you who are involved in computer science, it's effectively a key value per or name value per database. And namecoins are mined in a similar sort of way to how bitcoins are mined, except you can spend namecoins into the network in order to register entries inside that database. And one of the really cool use cases for Namecoin is to build a entirely decentralized DNS system. They even have their own top-level domain, which is called .bit. The only downside is that you have to install a browser plugin in order to see these domains. It's not perfect, but anyway, I could register like nikiwiles.bit. In this case, nikiwiles.bit would be the key in the key value per, and then I could set the value in the key value per to be like the IP address of my home web server. And then, provided you guys had the browser plugin installed, you could surf to my website, completely circumventing the entire global DNS infrastructure. This guy, Mike Ward, he's done the same thing, and he's sort of made himself invulnerable to censorship from the likes of ICANN. Okay, getting towards the end. Next quick use case is the idea of a peer-to-peer cloud. So the last 5 years have seen some pretty big growth in cloud-based services. Consumers love them because it's a great way to make your files, your email, all accessible from whatever device that you have that's hooked up to the web. Also, businesses love them because you can add sort of computational and storage capacity on the fly, and you can kind of scale it along with the needs of your business. However, these services are really centralized, and this has some implications for privacy, security, but also network availability. I mean, almost every cloud service provider has had a colossal outage at some point in the past, and I think it's only a matter of time before one of them gets massively hacked. But decentralized alternatives are just starting to appear, and they're aiming to be more secure, more private, have less or zero downtime. And this example, which it's quite unintuitive, it's pronounced storage.io. These guys are aiming to be between 10 and 100 times cheaper than Dropbox. And the project uses a blockchain to store information about file integrity and storage locations. And a peer-to-peer network is used to actually manage the heavy lifting of shipping around all the files. The rough idea is that you can share your spare hard drive capacity in exchange for some capacity in the cloud. Or you can actually sort of lease your spare hard drive capacity and get paid in the cryptocurrency of the network, which is called storage coin. And then you can either later use that storage coin to buy some storage when you need it, or you can sell it on a cryptocurrency exchange for bitcoins or dollars or whatever it is that you want. From a sort of practical point of view, the files are sort of shredded up into tiny chunks, and then they're encrypted and spread across the network. As with many cloud hosting providers, there's the idea that admins perhaps have privileged access to data in these different companies. With storage.io and other sort of blockchain-based solutions that are hopefully coming, nobody will have access to your files except for you, because only you will control the private keys that are necessary for the decryption of your data. Another one is ZenNet, and this is the same sort of thing but with compute resource. So the goal here is to build the world's biggest public supercomputer. So you get paid for your spare CPU cycles. When it's launched, these guys want to be able to offer huge computational resource, but at a fraction of the cost of some of the big incumbent cloud computation providers like Amazon Web Services and also Microsoft Azure. Next, take a quick look at the sharing economy, and all this stuff I think also is the same for social networking. I'm sure most of you guys have used at least one of the services on this slide. You know, Uber, Airbnb, and all these companies have a similar kind of business model, which is basically to build a big network that connects producers and consumers, and then to essentially sit in the middle of that network and taking a cut of all the transactions that take place. Now, I think that this entire space is ripe for disruption, because the value is not really so much in the technology, but in the network effects that these people have managed to accrue. And already we're starting to get some interesting projects in this space. This one is called Lazoos, and these guys are aiming to be a completely decentralized version of Uber. It's a ride-sharing company, but it's one that aims to be owned by the people who use the service. So there's no offices, not really any staff, it's just essentially a GitHub repository. It's in its early stages, but the goal is to build what's known in Bitcoin circles as a blockchain-based, decentralized autonomous organization. It's a decentralized autonomous organization. What that means is that the entire network is basically run off the computational and storage capacity of the mobile phones of the people that use the network. So no servers, you get the idea. So all handsets obviously have GPS these days, and the goal is to enable people to participate in journeys that are already underway, which is actually quite unlike Uber, because Uber is really more like a massive data-driven taxi company, but this really is intending to be like a true sort of ride-share app. So once again, in the Lazoos network, users pay for rides using the currency of the network, which are called Zoos tokens, and you can earn them by offering rides to others. And also you can sell your spare Zoos tokens on a cryptocurrency network in exchange for whatever it is that you want to buy. So to wrap up, as the world kind of becomes more data and less capital intensive, is there a possibility that blockchain tech could help us to build a more decentralized future? Here are some of my little hypotheses. Might we see, for example, in the future, a resilient peer-to-peer energy network by using really efficient solar panels on our houses? Something that will be transparent and would have local and decentralized markets for electricity that wouldn't be susceptible to the sorts of rate rigging and over-financialization that we're seeing in the bigger energy markets. What about using off-the-shelf networking gear to build decentralized alternatives to the web? So maybe even using like encrypted mesh nets and using blockchains to organize the network and to reward people for sharing their spare bandwidth. What about a decentralized logistics and delivery system, perhaps using off-the-shelf drone technology? And of course, there's the strong possibility that blockchain tech could form the foundations of a future Internet of Things. So IBM are really interested in this. It's quite possible that the backbone of a future Internet of Things could be built on a blockchain because it would provide that extremely high level of availability and robustness, and also it would be a natural place where Internet-enabled objects could collaborate with each other. There's an interesting project called 21, which is a new VC-funded project that They're trying to build chips that can be embedded in your toaster, your fridge. This thing will sort of sit there using your spare electricity, mining very, very small amounts of Bitcoin, and then it will effectively use the Bitcoin that it mines to finance its own communication with the network. To wrap up, for those of you who are interested in what sorts of projects are trying to make blockchain technology accessible for software developers, there's probably three big ones, and they are Ethereum, Counterparty, and Eris. Now, all of these projects have London meetup groups. I run the London Counterparty meetup group, which is held at the Pendrell's Oak pub in Holborn. So next date is the 30th of June, so if you guys are interested in learning more, do pop along. And that's pretty much all from me. Thank you, guys.
Many thanks, Niki. So what's different if you'd given this talk 18 months ago? Would it have been all the same, or are there lots of new developments that have taken place in these last 18 months?
Yeah, quite a lot has happened in the past 18 months. Some of that very last slide, which showed the three big players in the space of effectively helping developers to build out this decentralized stuff. Eris didn't exist back then. 21 Inc., the company that I mentioned about the embedded Bitcoin hardware, that didn't exist back then. A lot's happened in the Counterparty ecosystem, which is the project that I represent since then, including the idea of sort of decentralized smart contracts. A lot of VC funding as well has come into the space of late. CoinDesk do a State of Bitcoin report. CoinDesk is like a popular news source in the Bitcoin space, and they do a yearly State of Bitcoin report, which talks about the level of funding and the interesting projects. So definitely recommend pick up a copy of that.
And one more question from me before I throw this open. You gave examples of Airbnb and Uber, who are two companies that frequently are highlighted as very transformational. They're the examples of new industry. They've got rapidly rising share prices. Given that there is the potential that they may in turn be disrupted with non-centralized networks, would you be selling shares in these companies now?
Yes, as soon as I start to notice that that decentralized solutions were really starting to get traction, I might. But at the moment, I think that Uber and Airbnb are probably going to go up before they go down, I think. I mean, because these projects are in the very, very early stages. For example, the zoos, you could go onto your Android phone and download an early client, but it's going to be a long time. Like I would say, at least a year or two before we can figure out.
A long time, yes.
Yeah.
In this industry.
Yeah.
No, a year or two or so.
Yeah. I mean,
somebody could join one of these projects quite soon.
Yeah, anyone can. The good thing about these sorts of projects is that they all tend to be open source. So anyone who's interested in contributing can just go to GitHub and pick up the source and start, doing polls and helping to make the software better.
Questions from the audience. Anish?
I had two questions for you. It's mostly about what you said. I was wondering if you had data, one about the speed of transaction. So I'm very aware of the Bitcoin ecosystem. I'm from the board for Ripple. My day job is in a big bank, so I kind of know how transactions happen. So currently, we are nowhere near being able to do the kind of transactions that banks could do, at least peer-to-peer, or in that sense. Okay, first one. Second one is, are you aware of how IPv6 name translation works?
Vaguely.
Okay, so I was about to ask you this question. Given how difficult it has been to actually upgrade from IPv4 to 6, can you imagine how hard it would be for us to actually build a DSC based on blockchain or whatever else to have a naming system that's publicly accessible and usable?
So this technology so far is not competitive with what banks do, and given the slow conversion from IPv4 to IPv6, something I remember way back 15 years ago, people were saying it had to happen soon, and it's still taking a long time. So is this just getting ahead of ourselves?
Okay. So first of all, in terms of transaction speed, so I suppose there's two sides to this. There's how quickly it takes for a transaction to be received. That's actually very quick in Bitcoin. Half a second, something like that. In terms of how long it takes for a transaction to be robust in the network, that is, have enough confirmations for it to be secure, that's a longer period of time, an hour. Then the other side of this that you alluded to was effectively to do with the scalability of Bitcoin, which effectively has to do with the number of transactions per second that the network can cope. So I think it's estimated that currently Bitcoin can handle about 7 transactions per second, which clearly is not Visa scale, let's say.
Worldwide?
Worldwide, yeah.
Yes, 7 transactions per second. So if you go to a website called blockchain.info, then you can actually watch the transactions as they happen and as they sort of, you can see them. It really is something that you could watch without getting a headache. So yes, there are scalability issues with Bitcoin. Yes, the lead developers are trying to solve them, and there are also other potential solutions to this Byzantine generals problem that might give us decentralized options that can have a whole lot more scalability. So there are other sort of models out there. So this talk is about blockchain technology, but remember that blockchain tech is just one solution to the Byzantine generals problem that could itself be disrupted by other solutions that are faster and better.
I'm very aware. I did crypto before. I'm a cryptographer, so I'm very aware of the challenges. Most people need to ignore that. That's why I was.
Yeah, no, that makes sense. Thank you for the question.
Meg?
I used to run a forum that had a MySQL database, and somebody stole it from me. They took the whole database. So, would it be possible, the way the Bitcoin blob of data resides on everybody's computer, could we change it so that forums, instead of residing on one server, people just download blobs of data which constantly update, and they can communicate on forums that way nobody owns it?
Yeah, Ethereum is a project in particular that is interested in exploring these sorts of ideas. I think they'd like to build decentralized versions of social networks, such that everyone is not. So there are no servers effectively, so the services run off the combined computational and storage capacity of the people who want to use it, and the data is spread out in such a way that it's also resilient. So if your computer goes down, you don't lose everything. It's a little bit like I was describing with storage.io. The information is kind of sliced up and spread out in a redundant way across the network, so that and this process is kind of managed very cleverly to make sure that the level of redundancy stays at the same level, so that you're not going to lose data. It's fascinating. I can definitely see some. I would love to participate in a decentralized social network. One where all of the upside wasn't controlled by a single company. One where the benefits were spread out to the users. When I work in sort of digital marketing, and I work in the area of social media analytics, and the amount of information that we share and the value of that information to marketers is just crazy. There's a really interesting social network called Twister that is essentially a decentralized version of Twitter. And that works using a blockchain and also peer-to-peer swarms. And the way that they do it is that the information, instead of being held centrally, it's kind of held in a swarm by the people who are interested in that area of the network. So you don't have one party who has massive visibility of all the data, so they can use to monetize it effectively. You own the bits of the data that you care about.
So it's not that each person would have the entire copy of Twitter or it's on their hard disks. That's clearly not going to work.
Yeah.
But it's spread out in some small way that maybe the database exists in 100 different places.
In Twister specifically, a blockchain is used to store the handles, the usernames. It's used for identity, and then peer-to-peer technology that probably is closer to BitTorrent is used to provide for the storage and shipping around the large bits of data, like oh god, the amount of data that Twitter must have, exabytes, I don't know, you can imagine.
Andreas?
Yeah, I'd just like to add a bit to that availability and transaction speed to that there is a cat theorem known as Brewer's theorem, which says that it's impossible to simultaneously provide all three of the following: consistency, availability, and partitioning. And as I understand, Bitcoin effectively is like a single bank, and within a single bank, transaction happens very quickly, any single bank. But if you have multiple banks, now the question probably would be better how quickly you can transfer from one cryptocurrency network location to another cryptocurrency person. And then I think generally distributed computing is so complex, and from what I hear so far, I think it sounds very simple, and because it relates to money and all the other things, I wonder generally how we are going to manage. I mean, people will they need to know lots of those technical details to be in control of their possessions, of their information, of their currency, etc. And that maybe relates to BitNation, if you know, and maybe you could give us your opinion on BitNation, because it seems that there is lots of potential in that. My question is how will manage the complexity of that?
Yeah, well, we have a long way to go. I mean, for sure. At the moment, this technology is not user friendly at all, I would say. But it can be made user friendly. I mean, I see a nice trend towards the user interfaces improving. Also, I think that a lot of the stuff might ultimately end up being sort of hidden behind the scenes somewhat, so that a user might be getting the benefits of a blockchain-based system without even actually necessarily knowing that they're using one. So I wonder whether it's sort of hiding a lot of these details from the user is the key.
But when people use the World Wide Web, they don't necessarily understand how TCP/IP works.
Exactly. Yeah.
So the present interface is exposed a little bit too much of the plumbing. It has to be hidden away, so the complexity becomes underground rather than exposed.
Exactly. Yeah.
What about the comments on BitNation? You can tell people what BitNation is and whether you support it.
I know a little bit about this project, not a whole lot, but I think what they're basically trying to do is to see what sorts of properties of a nation can be blockchainized. So it's not really, as far as I understand it, BitNation isn't one thing, but it's a collection of different projects to blockchainize things like birth records, passports, property deeds. I imagine that all these sorts of things are in the scope of BitNation. Maybe it sounds like you actually know more about it than I do. Do you want to say a few words about?
Yeah, you're right. Basically, it's converting all political and even social welfare things to more decentralized and more inclusive environment. However, that's my main problem, is that I think when we have our, let's say, savings in bank, we want bank to be responsible for that. If we have our currency or social welfare or passport within our bit wallet somewhere in our computer, who is then responsible? How we make sure it is correct and we are not tricked by high complexity mathematics. And that's more or less new paradigm. I mean, is that technocracy coming, replacing democracy or something like that?
Yeah, I wonder. I mean, I can imagine how some accidental disasters might happen. In that kind of area, people accidentally losing control of their own identity if they're using a blockchain-based identity system. I think it was Vitalik Buterin, the guy who created Ethereum. I think he said recently that in the future it might be more difficult to change an identity provider than it is to change a nationhood. And yes, we're at the start of potentially quite an interesting journey here, and there are risks that have to be managed, but there's also potentially a lot of upside too, I think.
That's why we need to discuss them beforehand. There's a lot of hands, so yes, you?
A question about transaction costs. if I've understood correctly, transaction costs are compensation for the miners for producing the blocks?
Yeah, kind of.
But you also mentioned the asymptotic curve as it approaches 21 million.
Yeah.
Does that imply that the transaction costs will essentially infinitesimally increase as the the amount of computing resources in order to solve the problems?
Yeah. There's actually two different sets of rewards in Bitcoin land. You've got the reward that you get for successfully mining a block, and then transaction-based rewards. So the idea is that gradually the rewards for mining a block will disappear, and that they'll, in the end, future miners will be relying mainly on those transaction fees. So the rewards for mining a block get less and less and less. And then eventually what you have is people just swapping the same bitcoins around the network. So at the moment, miners get brand new bitcoins that never existed before, and they get transaction fees. When there's 21 million bitcoins, they'll only just get the transaction fees. And the theory is that by this point, the network will be so mature that it'll be able to support them. That's one of the unknowns, actually. That's one of the criticisms that people have of Bitcoin.
Question over there? The glasses?
It's Harry.
Hi.
It's a really interesting talk, actually. So I quite agree with you on the blockchain. Question is about Bitcoin. So Bitcoin has all the good things of blockchain, but then you have huge price volatility. As a currency, it suffers a lot of problems. Also the Mt. Gox and all kind of potential for money laundering and all the other things.
Yeah.
Then you have things like VEN, which is kind of managed by banks. So there's a tendency to kind of move blockchain-based technology into a conventional FX exchange paradigm.
Yeah.
How do you see that sort of, and also the issue with you can say that there's an issue or not, but then this fixed money supply at the end, it's a kind of monetary policy decision from Bitcoin. Personally, I think it's hard to say whether it's good or bad because that's the econometric question, right?
Yeah.
So how do you see that sort of transition, if there is any? That people using blockchain as enabling technology, but then conventional exchanges might take in the role of management.
Yeah.
You could explain to some of the audience who maybe don't understand the volatility issue, the Mt. Gox exchange issue, and then come back to this important question as to controlling the money supply. Maybe it's not such a bad thing if governments can actually create more money on demand rather than be constrained to fixed supply.
No worries. First of all, the volatility question. So I suppose there are two sort of big sort of charges leveled against Bitcoin in terms of it not being perfect. The first is the volatility. The second is the anonymity. The volatility is a big one.
The volatility means that the amount of money you can buy for a given dollar has changed dramatically.
Yeah, so if you look at the Bitcoin markets, the price of Bitcoin is quite volatile. So it's not uncommon for it to go up or down by 5 or 10% in any given day. So it's considerably more volatile than most fiat currencies, and that is definitely a problem that is going to sort of constrain its adoption as a currency. My personal feeling about Bitcoin is that it's kind of more like a commodity than it is a currency, and there are other blockchain-based projects out there that are quite interesting that are trying to solve this volatility problem. The one that springs to mind, and it's an experimental project, is called eMoney. It's actually made by a British developer. It's not quite released yet, but I'll see if I can describe some of the theory behind it. So, in the e-money world, it's not just the currency, but there is also a decentralized exchange that sits as part of the system. And the idea is that the e-money system itself can actually have its own balances, and it actually directly intervenes in the market through this decentralized exchange in order to algorithmically smooth out short and medium term changes in price. So again, this probably isn't perfect, but what it represents is people sort of taking steps in the direction to try to make cryptocurrencies that have a stable value. There's another one called NuBits, that's N-U-B-I-T-S, and that is a crypto project that's intending to make a cryptocurrency that is pegged to the dollar. Now, so far it's worked, and it's not just a purely software-based system. Actually, it has human involvement, so there's an extended human system around this project. But nonetheless, it's still managed to maintain within a few cents here or there. It's pegged against the dollar, so I recommend checking both of those projects out. What was the
Mt. Gox.
Mt. Gox, yeah.
The fact that although Bitcoin is meant to be decentralized, people put their Bitcoin into the exchanges, which then get embezzled or fraudulent things happen.
So, Bitcoin has a whole litany of, a whole history of big frauds taking place, big Ponzi schemes taking place. One of the biggest ones of late was the whole Mt. Gox debacle. Mt. Gox is, or was, a Bitcoin exchange that closed down quite some time back. Effectively, we have a situation where we have lots of centralized exchanges, and so you've got this decentralized currency that's being traded on centralized exchanges. So the way I like to describe it to people is, if you put your Bitcoin on a centralized exchange, you no longer have that Bitcoin. What you have is an IOU that represents a claim on that Bitcoin if you're lucky enough to get it back. And some of these companies are a bit shady. Several of them have gone bust, been fraudulent, dissipated the funds. The hope is that we can start to transition to a more decentralized way of doing things. There's already a decentralized exchange that exists. Counterparty has one. There may be others. What I'm not seeing is these getting masses and masses of use. Right now it's really niche. The reason people are still favouring centralised exchanges is because of the liquidity. There's so much trading volume that it's easier to get your orders settled at a decent price without moving the market too much. My hope is that these decentralised markets will start to gather some steam.
The last question is, why is it necessarily a good thing that there's a fixed amount of Bitcoin forever? Why isn't it a good tool that the governments may have to do a bit of quantitative easing?
That's a good question. Bitcoin was kind of modelled after gold, I think. I think what Satoshi Nakamoto was trying to do was build more of a commodity than a currency, and also this idea that you can have massive increases in price isn't a bad thing if you're trying to get people to adopt your product. So it's a nice little quirk of the system to get people invested in it and get people making some money. But it's not necessarily a good thing to have a fixed supply. Now there are other projects that don't. What I expect that we'll see is lots and lots of competing blockchain-based projects that have different monetary policies. And what we'll see, I kind of guess, and I think we're already seeing this actually, is these different projects will fulfill different niches. Many of them will fail, some will be successful, and I think it's a very sort of Darwinian ecosystem. I think we'll see some winners, and I'm not quite sure what the monetary policy will look like when it all shakes down.
Alan?
Yeah, this is very exciting stuff, and I'm completely convinced it's got massive disruptive potential. But I also imagine that there are institutions, organisations that are threatened by it because it's wresting power away from them, potentially. So what threats, serious threats, are you most concerned about to the realisation of these technologies that would come from, say, institutions like legal regulation or technology disruption in another form?
Yeah, the over-regulation of Bitcoin is, I'm talking about Bitcoin specifically here, but I guess it goes for all sort of blockchain-based currencies. Over-regulation is one concern, and that's what's happened in the States. They have this regulation called BitLicense, which is fairly onerous toward people who are involved in the Bitcoin ecosystem. But, for each jurisdiction that is harsh toward Bitcoin, it just creates an opportunity for another to step in. The Isle of Man is intending to be a really Bitcoin-friendly jurisdiction, and if this becomes really successful and the market becomes extremely valuable, and right now it's It's a $3.5 billion market, which is minuscule, really. You know, there are individual hedge funds out there that control 10 times that. So we're still at the very, very start of this thing. Extremely small market caps. So right now, governments are kind of paying attention, but I don't think they're paying serious attention just yet. So that would be one. Another potential, sort of hypothetical problem might be if a government decides to attack Bitcoin directly and to actually try to destroy it on the level of technology rather than law. So I mentioned earlier about how Bitcoin has a process of mining, and going back to the Byzantine generals problem, where you're trying to get a 50% majority agreement. Now, the way that Bitcoin works is that you can actually, there's an attack vector on Bitcoin where you can effectively take over the network. If you can amass a large amount of computational capacity, you need to get 51% of the computational capacity in the network. It's called the 51% attack. Governments could afford to do that. Like if they really wanted to, and they wanted to buy, racks and racks of hardware, shove them in a data center, it's within the remit of the US government to shut down Bitcoin tomorrow by attacking it at that sort of technical level. And there are other competing cryptocurrencies that are aiming to be more robust and are less susceptible to this sort of 51% attack. So I think it's a race that governments would probably lose. That's my hunch.
Question down here?
You talked about applications of different blockchain in disrupting the existing ways, business models. What about, taking certain vectors of these blockchains that cannot be done with existing business models? What are potential applications for that take the blockchain characteristics that we could potentially, so things that are not disrupting existing business models, but things that you can do with blockchain that cannot be done presently with what we have right now.
Oh, good question.
That's a good Harvard Business School question, yes. Got a Harvard Business t-shirt on there. So, not just doing the existing business in better ways, but doing business which was never before possible.
I don't have a really good answer to that question. The way that I frame Bitcoin in my mind is as a new type of decentralized data structure. I think that, if anyone here can correct me if they have any other ideas, but the way I kind of see it is that, at least in terms of sort of Bitcoin, the currency, you've got it could all be done in a centralized way. But I think what it can do is enable us to do things, faster, cheaper, in a way that's more robust, more resilient. And I do kind of see it more as disrupting existing industries rather than providing anything entirely new. But you could combine it with, all of these new advances that we're all interested in studying, like the Internet of Things. I think it can certainly. Do you have an idea?
Sort of, but maybe if David allows me to give my comments.
Yes, please, Andrew.
So, yes, I was going to give two of them, and both relevant to my fields and double personality.
Okay.
And one comment is obviously on what we call neurosocial network,
right.
Brain-to-brain communications, something we are building with friends at the moment. Well, I'm sitting here and they're building.
Brain-to-brain communications wouldn't necessarily want to involve a centralized.
Well, yes, because for different purposes, for instance, gaming being most obvious, it could be neuromarketing, it could be something else. You may want to make your brainwave data, not only brainwave data, but generally brain data, being publicly available, but at the same time this presents huge ethical issues because, for instance, by looking at this data, certain disorders can be more or less clearly identified, which is exposure of private health data. So you may want to publish, and obviously someone who controls all the brain data has enormous direct power over the individuals to whom this data belongs. So you may want to be very clear that it's A, decentralized, and B, you can't really identify whose brain data is that.
Okay.
So in this case, in terms of neurosocial networking, that would be just that kind of a novel opportunity, whether we're talking about neuromarketing or anything else, where the technology can be applied.
Fascinating. Neurosocial networks, everyone. It's gonna check it
Another
out.
comment or question?
Yes, which is on potential obstacles on the governance and compliance side, which could be a big problem. I mean, I would use security as an example. I mean, there is a need to do something that, for instance, Cloud Security Alliance is doing in terms of standard development.
Mm-hmm.
So we will need to have some sort of an ISA covering those areas or something else, because now I can see lots of problems how a corporate entity who would want to adopt this technology would actually face risks of losing, for instance, PCI DSS or 27001 or something else that they have, because there are obvious issues. You know, can you provide an SLA or an MSA from such a provider? Can you verify the security of the supply chain? Blah blah blah. And for instance, you know, if you are a CSO of a company which is dependent on it, let's say for doing financial transactions, and if adaptation of a new technology means you would lose the compliance status, then the clear answer is no. So they need to be there is a need of a major overhaul on the compliance and regulation side, which would allow companies to adopt these technologies without losing their compliance status and so forth. So it's could be a major blocker on the way.
Yeah. As I say, you know, good governments, I think, are just starting to weigh in on this, and legislation is just starting to appear. And so far, it's been a bit of a mixed bag. Some governments have come out strongly against it and want to try and impede the process as much as possible, and some are trying to step in and create lighter regimes. I think in 2 or 3 years, we'll have a much better idea, you know, what the sort of state of affairs is.
Does anybody want to make a suggestion about a new business area that might be open for this? And you may want to keep it for yourself. Joe?
Yeah, I think the other idea is to have independent agents that can work programs that basically are working and establishing the contracts and cashing in and progressively multiplying on top of the blockchain area I'm particularly interested in.
Okay. Brian, you have a suggestion?
Well, it sort of leads into another question I was going to have, but
Go for it.
specifically, is there discussion in the whole blockchain thing outside of Bitcoin, and it sort of plays into this, and that is anti-corruption sort of things. The idea that blockchain creates a record that can't be perhaps at all altered, if not easily altered, and though there is a fair amount of interest in anti-corruption, unfortunately the world is sort of still in the FIFA modality.
And anti-corruption is it's a property that sort of arises from the transparency that the network provides, and also, you know, the ways in which you interface with the network can be programmatic, algorithmic. Maybe fast forward to 10 years, we'll live in a situation where we have these sort of decentralized autonomous organizations where companies will sort of take the sort of standard processes that are opaque right now and replace them with visible, publicly auditable processes that are also driven by smart contracts. I think if one company does this and steps up to a much higher level of transparency, it might sort of raise the bar. They might see a stock price bump, and then maybe we end up with a situation where it becomes the industry norm to start doing this sort of thing. Like I gave the example of the local Bitcoin exchange, CoinFloor, who are doing, you know, are making themselves publicly auditable. This is giving you insight into the inner workings of the company that most financial institutions don't provide. That's a really small thing, but this technology certainly has the potential to make organizations much more open.
Time for a small number of new questions. Yes, here.
I have a macroeconomic question. Isn't this variety of cryptocurrencies creating actually quantitative easing? Because this is money out of thin air. And wouldn't this lead to inflation when they become more and more common?
Do the economists feel confident to answer that question? That inflation not just within one currency, but within all the finance which is available.
I guess one thing that happens is that your parity rate might...
A bit louder, Harry?
Your true inflation depends on the cost of commodities and your cost of kind of living, right?
Yeah.
So this might have a compensatory effect of the overall macroeconomic and the money supply, right? So if you look at a basket of things, how you value those basket of things using any of these currencies. So effectively that determines your parity rates between different currencies, right? So this is a very interesting thing. You are actually increasing your money supply by backdoor. So having more cryptocurrencies kind of means the central banks kind of lose their ability to control whatever they do, right? So this is, I'm sorry, I'm kind of interjecting. I have a question on that, but later on.
Yes, at the back. You should.
I have a question about the proof of work principle, and if we move
Louder, sorry.
The proof of work principle, and if we moved everything onto the blockchain in the ways you described, how much energy would that use? Would that be absolutely insane, the amount of electricity we would all be using to move everything onto the blockchain?
Yeah. I do have some good numbers somewhere for the total cost of the electricity that the Bitcoin network uses, and it is pretty scary. So yeah, this is another criticism that's labelled at Bitcoin in particular, and there are other sort of competing cryptocurrencies that are intending to be cheaper, and also entirely competing approaches that are intending to have much smaller energy footprint. One such example is a project called Peercoin that uses a combination of proof of work and something else called proof of stake in order to provide similar levels of security, they say, but at a much sort of less environmental cost. So,
quick comment on that, Anish.
So you actually don't have to have the same amount of security for all sorts of transactions, so you can actually have a variable thing. What I mean to say is like your hash functions doesn't have to be a 56. You could just reduce it. It's something very well known in crypto world, so you can do that. And then for the IoT things, you can just have like two bits of your hash chain to be validated for your house to be sold, then the whole physics. So that way you can scale it, and you can actually do what I would call like a knapsack, and then cost it down.
So there's diversity of possible solutions.
Absolutely.
Yeah. Question over there.
Going right back to your beginning, isn't there a kind of social or anthropological benefit to centralisation as a way of doing things? I mean, I just wonder if I'm, as somebody who's not a technologist, for all of this, if something goes wrong with the technology, who's accountable when it's a distributed network? How do you fix it? How do you, if you have a benefit of centralisation, surely you have one route to fix it properly.
Yeah, so what Bitcoin is and what blockchain technologies are, it's weird. It's kind of like centralization done in a decentralized way. So you've kind of got one database, but it's replicated. It's a weird sort of state of affairs. In terms of the practical point, what on earth do you do if there's actually a problem? I mean, this has actually happened in the history of Bitcoin several times, and what effectively happens is that you've got some people who effectively own the source code repository for Bitcoin, which is indeed like a centralized thing. Well, it's a centralized. There are people who have more control over the Bitcoin GitHub repository than other people. Let's put it that way. And what they do is they try and rush out a fix as soon as possible, and then try and get all the people to adopt it. So it's possible for decentralized solutions to fall down. And on the other hand, Bitcoin's been fairly robust, and there hasn't been a major loss in monetary value don't think in its history. So it's just about managed to scrape its way through.
Does that mean it's always kind of wrestling with the threat of the cabal emerging?
Are they?
Kind of cabal from really.
One of the big sort of complaints that's leveled at Bitcoin specifically is, okay, so we've got this decentralized currency. So why is everything so centralized then? For example, why is the Bitcoin Foundation that pays the developers? Why is it that there's only 5 or 6 main guys who are doing commits to the source code repository? Why is it that there is only 5 or 6 great big mining pools? So there are all these sort of, within the Bitcoin world, there are these centralizations of power. These are all problems that other projects are trying to fix. So is Bitcoin going to be, the solution that is, the most common in 5 years' time? Who knows? It could easily have been supplanted by another solution that is more decentralized.
So, Meg?
It seems that the biggest problem that Bitcoin suffers from is the problem that's plagued humanity from the start of history, which is the people that get in first benefit exponentially greater than anybody else. So what is needed is a better algorithm, something along, if there was a way to use identity, but keep it anonymized, but keep it verified, you could, in effect, issue everybody on planet Earth or anybody that signed up with a fraction of a coin every single day. And then the incentive wouldn't be to hoard, it would be to spend, because as more people get on and as more coins get generated, they, in a way, deflate. But ultimately, the algorithm should be written in a sort of way that maximizes the potential of society, kind of a hybrid between socialism and capitalism, where people are getting incentive to work hard, but at the same time, there's a basic income for those, because everybody on Earth deserves to benefit from the work that our ancestors put into inventing the light bulb. Although I wasn't directly related to. I'm sure my ancestors made rice for them the
and it's been tried. Somebody's actually had a go at doing just what you described. Well, there's several projects, but one that springs to mind is called an Aurora coin, which is a cryptocurrency that was designed with the people of Iceland in mind. And they did what's called an airdrop, where they effectively tried to give everyone in Iceland a certain amount of this particular cryptocurrency. Now, it wasn't managed particularly well, but the idea is there. Another quick idea that springs to mind as well is something called demurrage. This idea that you have currency, but you're kind of incentivized by the network to spend it because it naturally decreases in value over time. And there's a project called Fry Coin, I think it's called, which has this property built into it, where it tries to prevent people from hoarding the money and tries to get the money flowing around the network.
So we've time for a few more questions. Not many. There's people who haven't asked a question yet who wants to chip in before I go back. There's one at the back there, yes?
Yeah, just a question about scalability of the blockchain. You said that the blockchain, the Bitcoin, and everyone has to have that so you can validate, is gigabytes.
Yeah.
And one of the use cases is, for example, getting someone their first equivalent in the financial, in the developing world. Does that mean it's hard to use on mobile or in other aspects? If you live on a phone, can you use it?
Yeah, you can, but you have like a lightweight client, so you're not actually participating in the Bitcoin network as a node. So you're not, earning any mining fees. You are just using it. You're using the network in a much reduced sort of way. So you're using it to effectively look at your balance and to be able to spend your balance.
Can I answer that?
Yeah, sure.
So essentially, it's a logical timestamp. You don't actually need to have all the logical timestamp. You just need to get the last logical timestamp at your window, and then you could optimize that. Considering your risk, I can happily hand you how to do that. You don't have to download the whole block, is what I'm saying. You can just get the node that you need to go for in this particular sort of network?
So it is a good question, and there are people working on alternative solutions, which so Bitcoin may very well go the way of many other pioneering technologies, which shows the possibilities, and then it gets overtaken. After all, Amazon.com was not the first electronic bookseller by any means. And in fact, there have already been other digital currencies, as was mentioned at the beginning, and each such technology and each such product raises ideas and raises requirements which were not obvious beforehand. Then new players can come in. Brian, you had it.
Yes. Niki, I've been looking forward to this talk for quite some time.
You came all the way from Canada to hear this talk.
Actually, I came all the way from Google in San Francisco and Mountain View. So, but specifically outside of Bitcoin, which I'm not terribly interested in the currency aspect of the blockchain notion, I'd like to ask about the discussion within the industry, or whatever you call blockchain talk, of the scalability, not the scalability, but the scaling of the exponential Moore's law scaling. So as futurists looking deeper into the future, 10 years giving us 100 times improvement of all the computer stuff, 20 years giving us 10,000 times, and 30 years from now, 1,000,000 times more powerful everything. So is there discussion about where this can rise in that exponential growth?
The folks who are busily working on Bitcoin's scalability challenges are banking on just those sorts of trends, really, to keep them in business, I suppose. Especially, I suppose the two biggest trends that we're banking on, I think, are growth in network capacity, because they're moving toward...
Every 9 months, doubling?
Yeah, and we need it, desperately. Right now, I think the size of a block is very, very small, like a small number of megabytes. There's a proposal to multiply that by like 20 times. We need the network capacity to make that even feasible. And the blockchain right now, I think it's something like 16 gigabytes or something like that. When we jump up to 20 mega block, that's going to be growing at a much faster rate.
I remember when 16 kilobytes was a lot.
Yeah, absolutely. So these trends are our get out of jail free card.
And are you also banking that one particular trend will not happen, which is the breakthrough of quantum computing? Because some of the mathematical problems that you described, which require huge amounts of computation, might, in principle, if quantum computing scales up, you suddenly become much more tractable.
Absolutely right. Yeah.
Is that a threat to the blockchain world?
From the little that I understand about how quantum computers function, it seems to me like a threat. Sounds like a threat to me.
I mean, two bits. First is a hash function. You can't actually speed it that much, but your public key function, which is elliptical crypto, it'll be a linear thing. So you have to find an alternate solution. The basis of blockchain, the hash function will remain the same. I mean, not remain the same. It's like half the difficulty.
So you're not too worried about that?
I mean, if the public key crypto system breaks, shit will break.
Yeah.
Okay?
So there's many other things going back. All right, I think that's a fair point.
What about purely mathematical risks, similar to, for instance, solving Riemann's theorem for the RSA?
It's the same. I don't even know right now if NSA has already done it. I was a number theorist for a while. I never knew. I take the risk.
So, Harry, final comments from you?
Just a very quick question relating to this gentleman's actually. So, I kind of feel that Bitcoin is the wrong end of the solution for blockchain, because it has the volatile bit, the management problem and so on. But if you look at the central banking system, that's effectively what you need to solve, what you can solve using a blockchain. So essentially you can decentralize the central bank. So any clearing mechanism to that sense. So you could actually have a pluggable currencies to a decentralized ledger, which is effectively the virtual central bank.
Yeah, in fact, I saw a proposal kicking around the other day where, folks in finance are really looking at blockchain tech to improve the efficiency of their own internal systems. What we have right now is a situation where you've got all these major banks and they each operate their own ledgers, and each of these ledgers interact with each other, and it contains counterparty risk. So what about the idea of having one great big centralized ledger that's common to all the banks, lower the infrastructure costs, and make banking cheaper? So there's definitely use cases for this tech within mainstream finance.
And also all this sort of massive regulatory driven reporting stuff is actually an artifact of a blockchain. So if you think of all these, like what all the exchanges do, any liquidity provider these days has to give what we call SDRs, the swap data repository. So we have trillions of dollars worth of counterparty transactions that you have to kind of report. Blockchain actually gives it free.
Yeah, absolutely.
Effectively, you have to kind of decrypt. You have like a signature of each transaction, which is effectively your reporting.
Yeah, that's beautiful.
So let's pause these discussions for a moment. There will be a chance to continue these discussions briefly in this room, but we have to be out quite soon. And then we can continue at a pub which is 6 minutes walk away, which is the Marlborough Arms. If you know the way, you can go. If you don't know the way, you can follow one of the regulars who will show you where it is. So we will continue at least some of these discussions which deserve going into more detail. Before then, let me just briefly mention, in 2 weeks' time there is another London Futurists event called The Future of Business. This is to mark the publication of a new book in which there are, I think at last count, somewhere between 50 and 60 short chapters written by different futurists around the world on trends and analysis relevant to how businesses will be changing in the next 10 to 20 years. So I think there's a couple of people in the room who have contributed chapters to that book, and what we're doing in 2 weeks' time, we're back in the main Birkbeck building, not this offshoot, is that we'll be hearing, I think, from about 7 different authors who will be giving a 7-minute, 10-minute summary of some of their ideas. So there'll be a real jamboree of ideas about the future of business. There are many other London Futurist events on the website, which I'll leave you to read at your leisure. But one I do want to point out has just gone live earlier today. It's for a slightly bigger event. So normally we'd run these for about 2 hours. On the 3rd of October, so that's quite some way away, Saturday the 3rd of October, we're doing a whole day event. Might have about 10 different speakers, starting 9:15 in the morning or so. It's quite a struggle for some of you to get here by 2 o'clock, I know. You have to get up even earlier to get here by 9:15, but we're going to have a range of talks on the common theme of anticipating 2040, a roadmap to abundance, ? What are the steps needed to take full advantage of the capabilities of this kind of technology, many of the other green technologies, the breakthroughs in nano, bio, infotech and cognitech, and what are the steps to take to ensure that all these breakthroughs lead to abundance available for all, rather than for something that we're going to regret. So that's going to be an all-day meeting in Birkbeck on the 3rd of October, just gone live, so look that one up. The details aren't complete. I've only listed 4, 5, 6 speakers so far, but there'll be a few more added shortly. So let's come back to this event. I feel much wiser about blockchain now. I knew a little bit about the Byzantine general problem before. Good to understand it better now. And all the other things. There is clearly a lot of possibilities here. It is hard to know exactly what time scale they're all going to become relevant. So I'm going to encourage you to get more involved in that discussion and to see whether you may be part of some of the companies that are going to disrupt the existing players in here, whether it's banks, gambling agencies, communications facilities, and so forth, or indeed be part of brand new businesses which would not be possible at all without this decentralized technology. So maybe you will be back in Birkbeck yourself in 18 months' time talking about your insights into how these technologies come together for a different kind of future. So all of that's possible on the basis of what Niki has shared with us today. So thank you very much indeed.